Page 25. Page 25. Following? Quads, that means four-sided. Do you have your notes? No? Four-sided. A quadrilateral is a closed four-sided shape. No news there. The sum of, watch this, the sum of interior angles is always 360. Think of your square, 90, 90, 90, right? That's like my go-to, but for a rectangle, it's 90 on all four angles. So it's always 360. Even if you were to change them, it's always 360. So that is probably a good one to highlight because it's probably new to you. You know what? I'm just thinking the best way to remember is this. No, not two, not two. I need more coffee. Okay. But let's say this is your four-sided shape. If you were to cut it, a triangle adds up to 180, right? This triangle adds up to 180 as well. So that's 360. I don't know if that will help you remember. Two 180s is equal to 360. Anyways, goes without saying, some of you are just like, I know this, Mr. Erickson, don't keep making a big deal out of it. I agree with you. The diagram below shows various kinds of quadrilaterals. Each time you add a property, it results in a different quadrilateral. We need to be very specific when naming. And so I made this chart here to help you look at it. So quadrilaterals is just any four-sided shape. So I made it look different. Then you go off this branch here, the parallelogram branch. Parallelogram can split into two shapes, a rectangle and a rhombus. When you combine these two, you get a square. Okay, so this is kind of like a family here, but it's always under this umbrella. Then you have a standalone shape, which we call the kite. And on the right side, you have the trapezoids. So a trapezoid looks like this in general, and you have two in particular. There's a right trapezoid and there's an isosceles trapezoid. So you need to be familiar with these shapes. Notice this. You see this arrow going up? A square can always be known as a rectangle as well. A rectangle can always be seen as a parallelogram. So if you're going up the stream, you can say that's always the case. A square meets all the criteria of things that are above it. But when you go downstream, we say sometimes. So if I ask you, a parallelogram is always a rectangle, not really, not always, right? It would have to meet the criteria for that rectangle. So up always, down sometimes, okay? So watch for that. Let's go and talk about a bunch of properties. So for this, we go to 26. And I need you to have, I'm going to use 4 highlighters minimum, right? I might get creative and add another one if I need to. So I have 5 on standby. Anyways, so let me, and I'm trying to make it easiest for all of you to access this information. So here you go. Let's just start with parallelogram. Parallelogram is the umbrella for all of these. Okay, so this is true for all of the shapes, parallelogram, and all of these included. So there's two pairs of parallel sides. What does parallel mean? Parallel. When lines are parallel, what does that mean? Lines will never meet. Okay, so if this line is parallel to that one, they will run alongside each other and never meet, right? That's why we say it's too bad that parallel lines have so much in common, because they will never meet. Okay? That's the joke of the day there. So two pairs of parallel lines, I'm going to highlight that like this. And this is how we're going to denote that. This side is parallel to that side. So we actually go arrowhead. We introduce that arrowhead there. That's one pair. And then there's another pair right here. Let's do that for all of them. Right, so rectangle has that. So that's a property that you can label for every single one of these. Why is there two arrowheads for the ones going up and down and one for the going sideways? Well, because we're saying these two lines are parallel and these two lines are parallel, right? Like we're kind of saying which two lines are parallel. Oh, I forgot the square. Okay, done. The next property that's true for all of them is this one. Two pairs of congruent sides. Two pairs of congruent sides. What does congruent mean again? Anybody? Maybe I should specify that. Let's put that symbol up here. Congruent, right? Equal, okay? If sides are congruent, that means that they're equal in measure, okay? So if you have a pencil, I'm going to denote it this way. I'm going to say this side measures the same as this side, and this side measures the same as that side. Okay, and that's true for the rectangle as well. Same. Watch this though. What about a rhombus and a square? All four sides are the same. A square, you would agree, all four sides measure the same. So we can actually just go one line everywhere. All four sides measure the same. That's also the case with a rhombus. Rhombus is a slanted square. Let's call that a slanted square. That's what a rhombus is. A parallelogram is a slanted rectangle, right? But I think I'm just going to focus on that rhombus there. As well, the third property here, two pairs of congruent angles. I'm not going to label that because it will get too messy. But watch up here, the parallelogram. This angle here would be the same as this angle there. This angle here would be the same as that one there. So, and obviously the 90s, right? These two are 90s. They would be the same, 90 and 90, right? So keep that in mind. Next, diagonals bisect. Anybody know what that is? You should start handing out money. Maybe then you will answer. What does bisect mean? Something bisects. Intersect, bisect, cuts in half. You knew that. You knew that. Maybe not. And so I will just do this. There's a long diagonal and a short diagonal. And I'm going to use, I have actually a red and a blue pen for this one. It's up to you how you want to do that. But the long diagonal, I'll go with red. And short, just because there's going to be a lot of stuff going on here. And I want to try for you to have a visual when you look at this. So the long diagonal, I'm going to use a ruler because I know I'm going to get this wrong. The long diagonal goes this way, right? And the short diagonal, it's a shorter diagonal, goes this way. So the longer goes into the pinched angles, right? And then the shorter one goes that way. And you have to be very careful here. Once you have this done, they cut each other in half. So I already used markings. This side is the same as that. I've got two markings on this side with the two here. So I got to go 1, 2, 3, telling me that this stretch here is the same as 1, 2, 3 over there. And the short one is also cut in half. Watch this, guys. You've never seen this before, have you? 4 to say that this stretch is the same as this stretch here. 1, 2, 3, 4. Because if we had used 2, we would say, hey, it's the same as this side here, and it's not true. Okay. Let's make a big dot in the middle, right here where those two lines meet, right? So we can kind of tell what's happening there. Now we're going to get specific to this one. So everything before is true, but now we're going to get specific to this. And I'll say this, all 4 angles are equal to 90 degrees. And I don't know what color you're going to use. I'm going to use pink. And I'm just going to introduce that. Say, hey, what makes a parallelogram, right? What makes it turn into a rectangle? It would definitely be the 90-degree angles on the corners. And another thing is that the diagonals, would they measure the same, guys? Would there be a short and a long one, or would they be the same? They would be the same, yeah. So that makes it different, okay? So I'm going to use green for that. Whatever you have, just be consistent because it's going to come back later. So I'm just going to make your diagonals. I'm going to use a ruler for this. There you go. And I'm going to say that I'm going to go 1, 2, 3, 1, 2, 3. Can I use 3s again for this? Yep. And just make the dot in the center because they bisect, okay? They cut each other in half. So I know you're like, whoa, there's a lot of stuff that I need to know. Can I tell you this? Most of the time I will ask you to sketch one of these and just label 2 things that are true about it. Okay, 2 properties most of the time. So as long as you remember 2 things about it, you'll be safe. And you're like, well, how many things are labeled here, Mr. Erickson? I'm saying that the diagonals are the same. I'm saying that they cut each other in half. I'm saying that there's 90-degree angles. I'm saying that these 2 lines are parallel, so are these 2. I'm saying that this line is the same as that, this side is the same as that, this side is the same. So there's lots of stuff going on here. You only need to do 2 at a time. Okay. Next, let's do rhombus. This is specific to rhombus. specific to it. So all four sides are congruent. And watch this. This is a new word. Are you ready? Diagonals. Well, no, we use this in trig. Are perpendicular. Anybody know what that means? They meet at a 90. That's right. Hey, you want to know the symbol for it? This is the symbol. Okay. Looks like an emoji or something. And meet at a 90. Yes, meet at 90 degrees. That's basically what I'm trying to say there. And what color am I using? Orange. So I'm saying diagonals are perpendicular. Is there a long and a short diagonal? It's slightly slanted, so they're not going to be the same. So I'm going to use the same here. I'm going to use red, my red pen for the long diagonal. This is so exciting, right? On the day before the long weekend. I know. You won't stop talking about it once you get home. Maybe at lunch in the cafeteria. All right. They meet at a 90. So what's very specific about this one, you can do this with the orange highlighter or whatever you highlighted the diagonals with. That is very specific. That is now you're saying that is a rhombus. Okay. And they bisect. So we can go 1, 2, 1, 2, because I've only used one markings all around. And I'm going to go 1, 2, 3, 1, 2, 3. And let's go on to the square. This is specific to the square. All four angles are 90. Diagonals are, you can handle that symbol, right? And diagonals are congruent. Okay. So I did the all four angles are 90 with pink earlier. So I'm going to continue with that. Add it to my diagram. Diagonals are perpendicular. That's orange. So this is going to be very busy. And that all diagonals are congruent is green. I used green earlier. It's going to hurt your eyes. Okay. So there and there, as well as that. Look at all that mess there. And I know you know a lot of these properties, right? I'm not saying here I taught you something new or revolutionary, but if I ever asked you what's the difference between a square and a rhombus, how would you distinguish these? And in this case, it would be the diagonals of a square are congruent, not for a rhombus, not the case. Okay. They both meet at a perpendicular. They all have four equal sides. Their diagonals bisect. Okay, I'm not showing that here, am I? Dun, 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 dun. There. Okay, so fun stuff, eh? So this is an overview, but there's one more. Maybe one of the most helpful pieces is about to come, guys. Are you ready? If you take, this is obvious here. If you were to take the two angles here, what do they add up to? 90 and 90 is 180. Yeah. But the same is true for if you were to take these two angles, like this whole angle here and here also adds up to 180. Okay. Go up and do the same thing for these two. This is 180. And so are these two. They add up to 180 as well. It's on both sides, guys. Like these two on this side would also be 180. So how about we do that? Doesn't hurt. But do not make the assumption that they will add up to 180 this way. Okay. It is true for the rectangle, but it is not true for the slanted ones, right? So keep that in mind. Okay. Let's keep going, because this is just the parallelogram branch. Okay. The other ones are not as tricky. Trapezoid. So trapezoid is the umbrella here. And so I will just say, let's go overall here. Sorry. At the top of page 27, one pair of parallel sides. That is true for all of them. So let's highlight that with this one. I'm going to use this color. And you would denote that by just going, this is parallel to that. That's it. And same here. This is parallel to that. And then specific to this one is two right angles. So we're going to make the 90 there. And I'm not going to make this as colorful as the other one. You have two right angles there. This one has two congruent sides. Or one pair of congruent sides, but it's this one is the same as that one. Two pairs of congruent angles. Two pairs of congruent angles. And I'm just going to do, I'm going to use a highlighter for that one. I'm thinking, maybe let's not. I will use it for a different one. But this angle is the same as this angle here. It's an isosceles trapezoid. So you only think isosceles triangle. There's isosceles trapezoids. There are isosceles pentagons. There's isosceles shapes other than the triangle. And this angle is the same as this angle here. Okay. And I will say this, diagonals are congruent. That one I'm going to use a highlighter for. What did we use for diagonals? We used the green on the other side, so why don't you just use the same color you used for diagonals that are congruent on the other side. And we're going to do this. Do you think they're going to bisect each other? Does it look like they bisect? They actually don't. They do not bisect each other, given the fact that the top is shorter than the bottom. Okay. Is there anything else I need to add? Well, you tell me, Mr. Dirksen. I'm just writing this down. I hear ya. Oh yeah, this part. These two still add up to 180. So do these two here. Make sure you do that for. And you know what makes that happen? Is the fact that sides are parallel. That's why they add up to 180. The main reason why. So when you have parallel sides, you can bet that these two will be supplementary. We call them supplementary because they add up to 180, right? So keep that in mind. Can I give you a little warning? Sometimes a trapezoid is hidden in a triangle. Watch. Triangle, right? Trapezoid, right? It's a trapezoid. Doesn't that blow your mind? Not really, right? It's good with TikTok and everything. It takes way more than that to blow your mind these days. All right, so that's 180 right there. But also these three on the outside is 180 as well. Okay, so 180 for the triangle, but also these two angles are 180 as well. So keep that in mind. You're gonna have more and more tools. Your belt with tools is gonna get fuller and fuller as we go through this. Everything is connected. Okay. Oh. Let's do an exercise. If this is, follow me, okay? Stop doing that. If that's 60, what's this? If this is 60, this must be 120, right? Okay. What is this? 60. Why? Because there's a straight line here. You see that? So voila, right? So you can actually do a lot of things if you know your trapezoids. Okay. That's it for this. Remember, I will just remind you here, the area of a trapezoid is A plus B times height divided by 2. I asked you to add this to your study sheet. And you're like, what's A and B, right? This would be considered A, the short side. The longer piece is B, right? So you add them up, multiply it by the height of this thing, and then divide it by 2. And obviously this one doesn't have a height, but the height, not on this diagram, but the height goes right across here. So we're going to have to use some Pythagorean theorem to figure out the height in that case. Let's go on to the last shape, which is our kite. All right, let me just get my notes here in order. Okay, can I just say, when you see a kite, I want you to think of this. You ready? 2 isosceles triangles. Okay, think of, I don't want you to justify it this way, but I want you to think of 2 isosceles triangles that are stacked. Okay, so watch this. This is the same as that. And this is the same as that. Can you see the 2 isosceles triangles? Yeah, so sometimes that helps, right? So I will give you some properties. 2 pairs. Notice I use pairs, meaning there's 2 pairs of congruent sides. Okay. Diagonals. Do you think they bisect? Does one of them bisect? Diagonals are perpendicular. Okay, they meet at a 90. I used orange for that, I think. So you can go ahead and add the 90 there. It's 90 all around, right? Watch this. Shorter diagonal bisects. Shorter, okay? Very important that you get that right. I'm going to use pink, shorter diagonal. So you go to the shorter one here and just say, can we use 1 or 2 markings? You can't, right? It's already been taken. So 1, 2, 3, 1, 2, 3. So the shorter diagonal is bisect. Okay? I'm trying to not give you the ones that are going to give you a headache. So I'm just, oh yeah, one more. One pair, this is the last one, of congruent angles. You're going to have to do some memorizing here because I feel like this would take up a lot of space on your study sheet. So I would say don't do it. One pair of congruent angles. And which ones would those be? See how these two are the same for the isosceles triangle up here, and these two are the same for the isosceles triangle down here. So yes, they would actually add up to be the same. Or they would be the same, sorry. Remember, the sum, listen carefully, the sum of all interior angles is always 360. Remember that for all four-sided. It doesn't matter which one you're working with, it's always 360 for all of them. Okay, and that is it for all the properties. So now the fun part, which is sketching and doing that kind of stuff. So always remember, I can ask you for the area of this thing because you've got a bunch of triangles here. I can ask you for the area of the trapezoids. I can ask you for the area of the parallelograms, you name it, okay? So come with me. So we're going to take it a little easier today. Just getting you started with this. So watch carefully how I do this. It's an easy 2 marks if you know what you're doing. Sketch the following, clearly identifying 2 properties. You need to identify 2 properties. You can use markings, right? Watch what I'm doing though. Make 3 versions of each example. What, right? Why so many? Because I want you to start thinking about all the different ways of sketching it. So let's do the kite first. A kite looks like this. It's not a diamond, okay? I ask students like, hey, classify this shape. Diamond. It's not a diamond, okay? We don't have that shape in this course, okay? So let's say you want to do this one. This would be one property. That's one property right there. Need one more. So you want to do diagonals. So you go like this and like this. And you just want to tell me, hey, I know they meet at a 90. You're good. You get full marks there. 2 properties. Or I'm going to draw another kite. I'm going to say that I'm going to talk about the diagonals, but in a different way. I'm going to say that this one is the same as that one. And I'm going to say that this angle here is the same as that one. That's 2 properties, right? Full marks. Or, you're getting the picture? Let's say you want to talk about, yeah, you could do, this one is the easiest in my opinion, the 90, right? That's true. And one more thing that I haven't done before. I'm going to say that these two angles are the same. That's good. Like a combination that I haven't used before. So that's what I want you to do for all of them. And that'll be it for today. And then coming Monday, we're going to start working with them, doing some math with them, okay? So watch, I'm going to give you, I got really creative with them. And we're going to break them down, cut them up, slice and dice, right? And have fun with them. But for today, I just want you to be able to sketch them, okay? So go for it. If you're not sure, I will post the key to this. Thank you, guys. Go ahead. So you can peek, right? There's nothing wrong with peeking right now. A right trapezoid looks like this. Just make it look like a right trapezoid. Okay. And then I'm going to say this. There's not much you can do with this one, to be honest. I would say, hey, it's got a 90. I know that this side is parallel to that side. And for this one, that's about it. That's all you can do there. So obviously, if it's not possible, then you just move on, okay? Parallelogram looks like this. One could be this. Two pairs of parallel sides, property number one. What else can I say about it? Congruent angles. So which ones are congruent? Okay, so I will go like this. Dun, dun, right? Yes. Two properties, done, check. Or I can talk about the fact that the diagonals bisect. So this is the same as that. This is the same as that. And then you know what? I'm done with labeling sides. So I'm just going to go, this is parallel to that side. This side is parallel to that side. What's that? This is more than two? Well, the fact that the diagonals bisect, this would be considered one property. And the fact that there's two pairs of parallel sides, that's another property. Or you're making me be all tired, guys. I don't want to think this much, but you could say that. Trying to think of something that I haven't done yet. This is the same as that. This side is the same as that side. So side length and angle. So I'm going to go, this is the same as that. This is the same as that. That's good. Okay. And so on and so forth. Go and peek, right? So pages 28 to 29. That's pretty much it for now. And then make sure your study sheet is beefed up enough for an AC on Monday, just doing this kind of stuff, classifying, including